Welcome to the Advanced Software Architecture course. My name is Michel Chaudron, and this is the lecture Quantitative Analysis of Software Architecture, Part 4, on Reliability Analysis. The goal of this lecture is to introduce the concepts of reliability analysis and reliability block diagrams. Reliability engineering represents a subdiscipline within systems engineering, and it emphasizes dependability in the lifecycle management of a product. There are many ways to think of the reliability of a software architecture. Software reliability is a large field and part of the vaster field of reliability engineering. Reliability block diagrams present a good starting point to examine the reliability of software architectures because of their similarity to the components and connectors emphasis of software architectures. These diagrams can be used to provide an analysis of different competing architectures, and are also amenable to the attachment of other non-functional information such as performance or cost figures. What is reliability? Reliability describes the probability of a system or component to function under stated conditions for a specified period of time. There are several quantitative measures called reliability figures of merit. MTBF, mean time between failures, is a measure of how reliable a hardware or software product or even component is. For most components, the measure is typically in thousands or even tens of thousands of hours between failures. Reliability requirements are specified quantitatively using reliability parameters. The most common reliability parameter is the mean time to failure, and this can be specified as the failure rate, and this can be expressed as a frequency or conditional probability density function, or as the number of failures during a given period. Reliability increases as the MTTF increases. The MTTF is usually specified in terms of hours, but can also be used with other units of measurements, such as miles or cycles. Mission reliability is defined as the ability of a system to perform its required function for the duration of a specified mission profile. This perspective on reliability is useful for systems that are operated frequently or over long periods of time, such as most vehicles, industrial machinery, and electronic equipment. Reliability expressions. On this slide, we show a little bit of mathematics. The reliability of each component or block in a reliability block diagram can be given in a variety of ways. As the mean time to failure, as reliability percentage over a period of time, or as a failure rate. From a component's failure rate lambda, we can derive the reliability of that component over a period of time t using equation 1. In this, we assume a homogeneous failure rate. The MTBF is widely used as a measurement of an equipment's reliability and performance. This value is often calculated by dividing the total operating time of the units by the total number of failures encountered. This metric is valid only when data is distributed exponentially. So when you apply it, you should really check it. In many cases, it's a realistic assumption, but you should check it. Here's a simple example. A system has 4,000 components, each of which has a failure rate of 0.02% per 1,000 hours. Calculate lambda and the mean time between failures. So, the frequency of a failure of the system equals 4,000 times the failure rate of an individual component, assuming that they have the same failure rate. See if you can replicate this calculation. Now we have introduced the basic concepts of reliability and how to quantify. The lecture Quantitative Analysis of Software Architecture Part 4 is finished. In the next part, Part 5, we will continue with reliability block diagrams that illustrate how to apply this to a system. Thanks for watching.